This is the video regarding gait analysis I promised you a few days ago. So we're in a patient file. The first thing you might remember is to edit the steps, and that's just to make sure that the two footprints that you can see down here on the left and right represent the footprints that you want to use in the rest of the study. So you can scroll through the two footprints. If you can see this one here, the very first footprint, that's quite abnormal. Now that might actually be the person's footprint, but you can see there's a lot of abnormal loading along that lateral edge or fifth metatarsal. So we want to go along to the other footprints and see whether that's reoccurring or whether that is actually their gait. And you can actually see that was the only one, so maybe the first footprint's a bit weird. So we've selected the ones that we think represent the feet. What you can actually do is double click on a particular footprint, and then it will change that one down here. Sometimes someone maybe does half a footprint. You know, this one you can see there's no push off from the big toe, and so you can see it's analyzing it as a left foot. You can actually change that if there is an error by right clicking on the mouse or trackpad and changing that to the right foot. And sometimes there'll obviously be a half a foot, maybe just the heel at the end if they click the edge, or the toes at the start. And so you can obviously discount those. So assuming you've picked your two footprints, the next thing you will look at is, well, actually it will usually come up on this picture. So the first two things that I do is click this little cog here, and first of all click the foot frame. That shows the alignment, so it's the flow of how that person's standing. And then I tend to have the speed at about 200. If you look at it at 100, it's okay when you're really analyzing yourself, but if you're trying to demonstrate something to a patient, it's quite painfully slow. And so they don't always catch it the first time round. So having the speed at 200 helps. If you have it at 300, it tends to be a bit too fast. And then it whips through and they can't really see what you're saying. I tend to find that 200 is fast enough that you can see the flow of the footprint, but not overwhelmingly fast. Now, as you know, when someone's standing, there's normally a slight amount of external rotation. That's quite normal. So you can see already, I mean, we can look at the data in the middle, but you can see already that actually these are quite straight. And then the data in the middle will actually tell us which one. So here's the foot angle here. And you've noticed there are two with numbers outside. So this is the data of the actual patient, left and right. And then these two have normative values. If it hasn't got a number next to it, it's because there isn't a normative value. So we're just going to compare left to right. So you can see the foot angle, which should be between 9 and 15 degrees, is 0. So very straight left hip. And then slight external rotation of 7, so still low on this person. You can see here the global index is basically the percentage of the foot used, and you want someone to use between 80 and 99% of their foot. And so they're both within that range, but just particularly on the left. So this person, which is actually me, is a tendency to have less pressure going through the left foot. And the rest of these you can obviously assess yourself. You don't really need to know the length of the foot. That's more for us when we're designing orthotics, obviously, to make sure that the orthotics fit their feet and their shoes. But some of this is interesting. The surface is probably less interesting us as biomechanical experts, but the load's important, the percentage load. So this breaks down the different parts of the foot. And whilst there isn't a normative value, I'll be looking left to right. You know, there's a few percent difference left to right, left to right. When we look at the metatarsal heads, there's a much higher percentage on the right-hand side as there is on the left. A few percent difference on the metatarsal heads of 2 to 3. So it's the first metatarsal head that's an issue. And then you can go down seeing which ones are different. There is a slight difference on the lateral heel as well. Now, when you're looking at the foot frame, which I'm actually going to remove to make it easier. You can see this white line, and that's the path the foot takes. So where it hits, the foot strike, and then what happens, how it follows through, and where it finishes. You can see there's a slight deviation in that foot. Now, we would normally want a slightly posterior lateral heel strike about here in the normal person. Then it will run through the middle of the foot slightly laterally. It would then start to move over, and normally push off is through or between the first and second metatarsals. So there is an abnormality. It's very central, very straight, quite a lot of load in that central metatarsal area. And then the load almost looks like it backs off and does a loop backwards, if you can see that. So there isn't a real push through the toe. Now, from my experience, I have overpronation quite predominantly bilaterally. So we'll have a look at the right one separately. But also some stiffness from lots of running in the past in this toe. So I'm obviously trying to take the pressure back off that. And I do find now that if I'm standing for a long period of time in shoes that do not have a lot of support or a lot of padding underneath, I can actually get some metatarsal pain, and particularly on the heads. And you'll see a little red spot there and here. And so I have identified that it's good for me when I wear orthotics. Then I tend to have a material called Poron, which I think you guys know because I've seen it on the Scoli brace website, and we actually put a 4-foot dip and then fill that dip up with Poron to reduce the load going through here. Looking at the right foot, again central, we'd like that to be a little bit more lateral. Smooth the gait line, and then a smoother push off through the toe. We do see pressure building up across the metatarsals, but it's smoother. It starts slightly laterally here and then spreads across. That's probably my body overcompensating with a slight amount of inversion to allow me to develop an arch that I know that I'm going to collapse otherwise. So I think that's probably a learned process, either conscious or subconscious. Now you can look at the rest of these buttons. This one here, gait cycle, is only available on platforms that capture 1 foot and then the other, which is why we've recommended 2 platforms. A larger platform, the ones that have the 120 I think that you're using at the moment. Again, there's the little cog, and we're running at 200%. It seems quite slow, so I'm going to speed it up to 3. And the interesting thing is a straight line. What does this one do? Straight line, yes, straight line. That's quite an oblique movement. Obviously in nature, in the human body, you would expect these movements to be quite smooth rather than sharp. So it's like I really want to take all that pressure, and we know from the image that happens in the midfoot. So I'm trying to avoid using my left hallux. It's a bit smoother here as we transfer off the right, but you get the gist. There's some numbers which we ignore because it's not really relevant. You can look at the frame set, which I never do because who needs to know each individual frame, and you can look at the average footprint, which again we ignore. And if you remember, I showed you when we go to prescribe a pair of orthotics, when you do an export, it will ask you, do you want to average the footprint? Always say no, because remember, going back to the beginning, we had some abnormal footprints. We had that very first one that was a bit weird, and in some people you might have half footprints, and it will average all of those, so it will actually mess up the ideal data, and that's why you want to avoid these footprints from the average. So this is a summary of the dynamic pages. We're going to roll on to the curves and graphs. And just for reference, I'm not actually going through the static, because the static, again, would literally just show you these load areas, and then obviously center of gravity, weight bearing left and right, and obviously you can work that out yourselves. Now on here, you can select what you want to show in these graphs. So of course, you want the left foot on the left, the right foot on the right, and then you've got the option 3 graphs. This is currently showing surface, so the amount of foot that you use. the load going through it, and pressure. There are other things you can use, but most people understand pressure and not really understanding in things like force. But rotation can sometimes be interesting, and that's an interesting graph here. We're going to go back to the one that's actually maximum. There it is. So obviously what you never want is to have two different graphs being displayed, speed and maximum, because we're always going to be comparing left to right. I know I'm stating the obvious, but this is a training video. So we're still using those two footprints that we utilized. A quick way of looking at this is the red line is what happened, and then the shaded area is the deviation across the other footprints. So effectively this is the data from the footprint, and then this is the range around that. So it's given us an idea that this is quite a nice, we've picked two good footprints because it's a nice range within the center of most of the other footprints. And effectively I see these graphs as, view them like a car. If you're driving a car around a racetrack, you want a smooth power distribution and you don't want any abnormalities and blips. So if you look at the load of my right foot, it's a high power band, almost as if this is a car that's where I'm changing gear, which is right because I'm actually offloading the foot. I'm pushing off my big toe and then the actual load going through the foot is reducing. So this is quite a smooth one. This is weird on the left. So it's an increase. My body starts to decrease the amount of load. Doesn't really know what's happening, but it has to increase load at some point because we have to push off the midfoot. So this is midfoot and this is the forefoot. So we have to push off somewhere, but quickly trying to get out of it. So it's not a smooth power distribution. It's the same with the amount of the foot I'm using. It's very, particularly here, where my body is hesitating to start increasing the load. I know that I don't want to put pressure through that foot. And when I say I know, probably all subconscious, my body knows that it doesn't want to. It's trying to not really use the foot, but it has to eventually, otherwise I wouldn't be able to walk. Then the maximum pressure again is abnormal on this foot. They both follow a similar pattern, but you can see this is a smooth graph. And we want smooth distribution of force, pressure and power. And we can look at other cases if you wish in the future. Now, if you do have video acquisition, if you've got that set up, you can actually click the video play button here and that will actually play the videos. Yeah, sorry, I've got to start it again. And then it's showing you the video with the footprint on each one. So if we go back to the beginning, because remember that first footprint was quite weird. I used a lot of my lateral foot. If we watch what happens, yeah, a little bit of a rock. But as I say, I would always ignore the first footprint and definitely the last footprint. As for what you're looking at here on the right, you can see again, surface, load, maximum pressure. We've now got 4. This is the average pressure. And again, you're looking for smooth bands, smooth power bands. So you can see in load here, you can see the abnormal blip going through here. You can, sorry, this is the baropodometry, but you can look at frame sets, kind of pointless because you've got the video here and you've got the step cycle and it's just data. So I only ever use this view here. The video is great if you're not sure what is happening in the graphs. If you can't read the graphs and you're not quite sure on the biomechanical analysis, then the video is great to see. Maybe it might be coming from hip, knee, and trying to work out why it's happening, which is important. And obviously, as you know, the summary report is just something for the patients. So I'm just going to close that and I'm randomly going to pick another patient and just go through really quickly. In another patient, we've selected our 2 best footprints and we're going to go to the biomechanical analysis. We're going to click the cog in the bottom and click foot frame. And we're going to change the speed to 200. You can watch it a few times just to get a grasp of it. You can add or remove the numbers, the numerical values. but they're always quite handy to have on, so I never touch that. So again, quite a central strike on this side. On the left, running quite evenly. This is the white line we're following, but it does, whilst it wavers through the midfoot, it does, I think it tends to push off the second toe, if I'm not, yeah, for the second toe. You can slow it down to 100 or even slower, of course. If you really want to examine something, you can go super slow. One of the things you will see is this hot spot that appears on the 4th, 5th metatarsal. That's not good. That is actually an area of pain for him. Quite an even flat pad of pressure of red in the forefoot. But what's interesting to me is, well, first of all, there was an abnormal load in the rear foot. It wasn't a smooth circle. But there's red here appearing through the midfoot. But the whole time that the forefoot pressure is appearing, he's still applying pressure through that midfoot. That is abnormal, and that needs to be dealt with, particularly because he does get pain there. If we switch over to the right side, and I'm going to speed it back up again so it's not painful to watch. You can see there's a spur, like a spike of red that goes through here. Again, that's abnormal. It follows the right path. We do actually want it to take that path, but not this fire of red that happens here, almost like a splurge of lava from a volcano right here. And that's very interesting, because if you look at this gentleman's x-ray report from the hospital, he has a heel spur. And so this person has been diagnosed with bilateral plantar fasciitis, with some metatarsalgia on the left. So this is showing it perfectly. And I would say probably if you look at his big toes, slow it down again, probably he's also got a little bit of hallux rigidus. I think he's in his early 60s, so he definitely needs some orthotics and some work through those feet, as well as balancing pelvis and everything above. Numbers wise, his centers, the amount of force he's using for his feet, is reasonably the same and within normal limits, but a very straight foot on this side, and the exact same number on the other side. So both straight, like he's skiing. The loads going through the feet are relatively even, but again, met heads 1 are slightly higher on the right hand side, and you can just look at the data from left to right, a little bit higher on the medial head, medial heel on the left, but again, only a few percent. Looking at the gait cycle, it's showing you the line of best fit here, and again, weird distribution as he pushes off. And so again, that tells me there's probably some hallux rigidus. If you had a shockwave machine, I would do some shockwave on his right heel around the plantar fascia insertion, and then through the hallux, or gentle mobilization adjustments, etc., etc. Looking at the curves, which is I think the one that you want the most help with. Big distribution of averages, especially on the left. Can you see this right one has a line and then not much shadow behind it? And the same with the load, a little bit different on pressure. But with the left foot, it's a very high variability. It's like his body doesn't really know what it wants to do. Each footprint's slightly different. It's like his body doesn't really know how it wants to walk. There's a lot of variability from footprint to footprint, and that's the same whether it's the surface, the amount of foot he's using, the load, or the maximum pressure. But again, we want maximum distribution. So there's a dip here, which is abnormal. Then we can see another dip here, a tiny dip at the top, and then a smooth drop. Not great on the other side either. A dip here, and then really funky at the end, which is why I think he's got that hallux rigidus. Looking at load, a dip here again, so his body is hesitating as it pushes off from the heel into the midfoot, smoother through the midfoot, and then a massive drop off. On the right hand side, a smoother power distribution, a little blip here, little blip here. No one's perfect, but that's a sort of smoother arc. And then in terms of the amount of pressure, who knows what's going on. There's a high here, and then a drop, and then through, and then a literal plummet. Now what's interesting on the right hand side is this is exactly where his heel spur is. So it makes sense that that's actually the bit that his body, it knows it's there and it's trying to avoid it. And then a nice sort of smooth drop off at the end. And there's no video with this patient. I'm happy to do more. I'm happy for you to even send patients over. You could send us a file where you export their data, and then you can always, there's the import export button here, and you can always send that to me. I can have a look at it and either send you an email or a quick WhatsApp or even a video, if that helps you understand what's going on and sort of cold read a case and see whether that can help you. I'm more than happy to do that. Any questions, just give me a shout. Take care. Hope to see you soon. Bye.